which is going to, so this recording will be specifically about creating this little histogram. Okay, great. So where's my AnyLogic? Here we are. Okay, so we go to main. We're doing something across the entire population, namely summarizing the number of connections people have. Okay, so let's go to our palette, and we're going to go down to the analysis area here. And you'll notice that there's something called histogram data, and then there's something called histogram. And we're going to need both of those. We're going to have a histogram object, okay? And I'm going to situate it uncharacteristically just above this. Why? Because we have kind of the display of the network going on below this area. I don't want it to kind of get in front of that. So I'm going to drag it here. So what did I do? I went over to palette, I went to main, then I went to palette, and I dragged in from histogram here, okay? So that's one piece of it. The second piece, I want to drag in histogram data into here. And this will be contact, I'm going to call it degree histogram, because we talk about degree centrality in social network analysis, the number of people to whom a person is connected, of other people to whom they're connected. So I'm going to call it degree histogram. Maybe I should have called it contact degree, but I'll call it degree histogram, okay? And within this context, we're going to specify certain things to complete it. We could specify whether it calculates a cumulative distribution function or just a probability mass function. I'm going to unclick CDF. So we're just calculating probability mass function, sort of the number that fall into different bins. Number of intervals, sure, we'll leave it at 10, okay? And the most important thing that it's going to want to know is what to show. What things are we going to show within this? Like what do we want to plot within this histogram, okay? And I'd like to be able to give it something here, but we want to actually show for each person in the population what their degree is, okay? So we're going to need to actually insert into this histogram information for every person what their degree is. So in order to do that, what I'd like to do is I'm going to actually give a brief glimpse of something we'll be seeing after lunch. And it's up in this general area, and it's called an event, okay? So this event, we're going to drag in an event here, okay? It's in the general area of the palette. Drag an event, and this will be called record histogram data. It's going to, so record histogram data. It's going to occur on a cyclic basis with a recurrence time of 1. Okay? And at this time, we're going to actually go insert into this histogram the number of people to whom every person in the population is connected in turn. We're going to add in for the first person, for the second person, for the third person to whom they're connected. Okay? So this is an event. It's going to fire off at time 0, starting at time 0. It's cyclic, and it's going to fire off every time unit. And we're going to go in there and we're going to report how many people are in the have a certain number of connections, okay? You know, I made it cyclic here, but nothing's going to be changing in this, so I think actually I'll backtrack on that. I'll just say it occurs once here. We actually don't need a cyclic one in this case. In general, we will to keep track of things changing over time, but in this case, the number of connections is not changing, so it just going to be occurs once, okay? And in the action, this is where things are going to be, this is where the rubber meets the road. In this action, we're going to say, for each person in the population, record in this histogram the number of connections that they have. So this is what I'm going to type. This is your first example of a more sophisticated Java statement. I'm going to insert what's called a for statement. And I'll type this out, and then I'll show it on the big screen. For person P in population, okay, this colon means in the population. For each person P in the population, I want to insert into the degree histogram. I'm going to tell the degree histogram, hey, add this person's data. Dot add, and I'm going to add in their data. Person dot get connections number. That's the number of people to whom they're connected. So I'm going to put this up on the big screen. Okay, boom, there we go. And this is what I put. This is what I put. Now be careful. TAs, prepare for deployment. Okay. So, for, and mind your parentheses. These are parentheses, not square brackets. They're not these things. They're these parentheses. This is person space P colon and then population. Okay. In Java, in general, Java doesn't care how many spaces there are, as long as there's a space between this and this. You can't combine them. This is the name person. It's saying for every person in the population, every P in the population, who's a person, by the way, you do this. Okay. Now this here we're telling it, hey, histogram, go add to your data this data point, this person's count of connections. That's his get connections number. Now, where does that get connections number come from? You might want to spare yourself brief get connections control space, get connections number, just like that. And we need this semicolon to tell it, yeah, this is something we telling it, do this. And we're not simply saying calculate some value, do this, and so we need a semicolon after it. Okay? Okay, who needs TA help? TA help deploy to the back. The rear sector requires deployment. Yeah. Okay. Good question. I was wondering if someone might ask about that when I tell you that colon. So colon in some cases, if it's coupled with a question mark, it means otherwise. So it can mean, if it's with a question mark, if it goes with a question mark, it means otherwise. Here it means in this thing. I'm sorry, I wish it weren't that way, but I tell you like it is. But yeah, it's disconcerting, but it's okay. So is that who else needs TA help? Okay, so we're almost done. What we need to do, though, the final thing, Kurt, mind my next step here. The final thing we need to do is, in this, we need to tell it, take its data from degree histogram. Okay? So this graph, we tell it, hey, take your data from there. We have to do add histogram data, and we're going to say degree centrality, and the histogram will be degree histogram. Okay? Okay. There we go. So big picture, what have we done? I'm going to use this to review the steps. Okay? So what I did is, I did basically three things here. I added this graph, I added a degree histogram object, and I added an event. Let's talk about how these work together. The whole is greater than the sum of the parts. I added this event. This event, on a one-time basis, occurs once at time 0. It's going to go through the entire population, and for each person, it's going to record the number of connections they have in this degree histogram. This degree histogram, on the other hand, is going to be just sitting there awaiting data. And this histogram chart is going to draw its data from, it's going to display it, but which thing is it going to display? This degree histogram. Okay. Final thing I wonder may be needed, I'm not sure it will cause a problem, but with degree histogram, I'm going to make it do not update data automatically. We'll update it. We don't need it to do anything. So I'm just changing it to that. I can't remember. It may work just fine without that, but I can't remember for sure. So degree histogram, there's a thing that says data update, and make it do not update automatically. Okay? Great. So should we run it? Okay, thank you. I admire enthusiasm. Okay, so there we go. There's our degree histogram. Okay. So here we have quite a large number of people with 10 connections, smaller number 20, 30, 40, 50, etc. Okay. Let's go. Okay, who needs TA help? The TAs are willing to serve. Okay. Okay. Folks, let's go now change the network type. Let's change it from a scale-free to a small world network. Okay? Small world network? Let's run it again. Okay? And let's go scroll up. We see a very different sort of network network degree distribution. Let's go change that again. That type of network connection. Let's change it to a random network connection, a network type. Let's run it again. Okay, run it. Here's a different degree distribution. Yeah. Okay. Okay. Several. Okay. Yeah. Okay. Okay. So, you want to see that histogram or where do you? Okay. It's up at the top. Yeah. Okay. Where's the zero? Oh, okay. Yeah. It's in that. Yeah. Okay. So you want to see where we can? You go to main, and then you go down. So how do you move down? Scroll down more, and it's here. You can change the network. You can also right to. And then you have to scroll it down. Okay, who needs professor help? Okay. And I do this right click and you can bring it. Yeah. So usually when you do it, run it again. Okay, so now we have okay, this is because they all have two, and the ring lights at all exactly two connections. So let's change this to, say, a scale 3 network. Let's try it now. Now you've got, from the back here. There was a question from the back about a certain apparent pathology noted. So if you have this to be a ring lattice network here, and you get this. The reason is everyone with a scale-free network has the same same number of connections. Okay. Okay, folks. I would highlight another thing here. which will also be, I think, of considerable value to you. And specifically, well, I should finish explaining this. So everyone within this context has exactly 2 connections. Within a ring lattice, your number of connections is exactly 2. And hence, it's showing the histogram as being, only exactly 2 connections. So there's no diversity in it. By contrast, if we went up to this, and we did a scale-free network, and we run this, now we have this sort of pattern because there's variability with a scale-free network. Similarly, if we did a random network, there'd be variability for a random network as well. Okay, here we go. So for a random network, there's variability as well. But for a ring lattice network, there's no variability. Okay? Okay, so I will just close this with a final point, and then we can break for lunch here. We've accomplished our goals for the morning, but I wanted to highlight one additional feature you may find of great practical significance. So let's suppose we were to run this, and I would highlight the fact that with many objects in AnyLogic, you can actually go retrieve data about them by clicking on them. So if you click on this histogram here, for example, you could do copy, and if then you secure recourse to a program such as Microsoft Office, Excel, for example, we can paste these in. It will paste in the histogram here as created by this. Similarly, you could go over here and to this, and you could do, copy the chart image, or indeed copy the data for the chart, or copy the chart image, and we can paste those elsewhere. So you should be aware that a lot of these visual objects within AnyLogic are designed to allow for easy export upon demand. Okay, and we'll expand upon that later as we see additional types of items you can embed. This degree histogram is just one of many types of structures that you'll find of value within the analysis form here. Some compute statistics or maintain statistics, maintain data accumulated over time in your model, maintain 2-dimensional histograms, or plot things out. And these things are designed for visual manipulation and export if you see fit. You can also export them easily via the program by pressing a button and put it to a database or to an external file. Okay, so we've accomplished a lot once again today. We've seen 2 big things. Number one, we've seen how messaging, we started the day, innocent to network connectivity and interaction between agents. We saw how we could add in a network by going back up to main here. We could go down and select the network type down here. We started with a distance-based network, connecting people if they're close enough together, but we went through a broad set of networks later. And then we saw that in order to enable that, in order to make it visible, we needed to go to person, and we needed to go up to their connections here, which are maintained automatically by default, and we needed to select it so we could draw a line between agents. So it would connect up the agents so they were visibly connected. They're still connected logically without them, but this allows you to see it, which was useful. We then learned how we could send messages over that network, such as with this send. So periodically This one sends to a randomly connected agent to whom they're connected, to one of their network connections. And we could receive messages via a transition type here. Receive a message, and we saw, moreover, we could have a contingent transition. In many cases, they'll end up just going back here, but in some cases they'll go here. So think about, someone sneezes next to you with a certain low probability you'll get infected, otherwise you'll stay susceptible. Or the transmission of an idea. You see someone engaging in some behavior, sometimes it influences you, sometimes less so. We saw that within that context we could have agents communicating with each other, interacting over these networks, and we actually implemented a spread of contagion across the network, but to do that we needed somebody to start infected. Someone made that prescient point. I noted that there were 3 ways we could easily deal with that. We could have us click on someone, they get infected. I haven't shown you how to do that. We could have the environment send a random person a message. I'll probably show that in a later lecture as well. Or we could start people in different states. In this case, we chose to start 1% of the people in the infected state, otherwise none. And otherwise start susceptible, excuse me. And that allowed us to have a heterogeneous population from the get-go, which allowed that infection spread. Finally, after going through a variety of network types, we added another output mechanism. We added in this thing which accumulated histogram data. We put a mechanism, a chart, which made use of that. Like other AnyLogic charts, they're often very easy to configure. You click this, you say on what data it depends, namely the data in here. And then we had this little event which which went off at the initial time, and which went through the population, and for every person P, it got the number of connections, it added it to the histogram data, and accumulated that. And that allowed us to do this histogram of the number of connections people have in the population. It also allowed us, by extension, when we run the model, to easily export this data. Okay? Yes. Thanks.
I wanted to make sure I understand the importance of the naming when you wrote that expression for the event.
Yes. Yes. This guy here? Yeah.
So
this is actually his statement.
Person,
Yeah.
So P is, you can use whatever you want.
Yeah.
The person refers to that class of agents that we call persons at the bottom, right? So that's really important that we're referring to a person that was named in that menu here. Over on the side. And then population, the same thing, right?
Right.
The population of persons that we also named when we placed them in the
It's a very good point. So within main, the reason that population appeared there is because we had in main, we have the population called population. If we had called this top, we would have needed within that event to say for each person P in pop, do this. P is our choice. It's a little bit like we call a dummy variable in math. I mean, it's sort of it's just a name we can choose for whatever. Person is referring to that each of these things there is a person, and it needs to know that to, for example, be able to ask how many connections they have, that sort of thing. We have actually a bit of flexibility about that, but basically, yes, you need to sort of tell it what sort of thing it is. The person. So for each of these, we call this a statement rather than an expression, because it's actually not computing a value. It's not like just a formula to produce a value. It's actually doing something. So in the statement, we're saying for every one of those persons P that live in the population, do this thing, and it'll do it for each one in turn. And for each of them, it's getting the number of connections that they have. This is an expression. Gets the value, the number of connections they have, and it then adds that to the histogram. This is saying, hey, degree histogram, you add this value in. It gives this value and it adds it to this histogram, degree histogram, and then this dot gets kept.
So degree histogram is our name.
Is our name for that thing called degree histogram. Yeah.
And then dot add is actually a function.
So we think of
Well, add is the function.
add is the function. The dot refers here, and I've been subversively weaving this in here. It's good to have someone ask about it. The dot is basically saying, okay, to whom do you want to address this? And when you're saying add this, who to add it? Well, degree histogram add it. You could think of it as kind of an apostrophe S in a way. It's sort of saying degree histogram, to degree histogram, do this add thing. And similarly, this is saying for P, ask P for its number of connections. So this is addressing P and saying, give me your number of connections. This is addressing degree histogram and saying, hey, you, I want you to add in this number as returned by that. Does that make sense?
Yeah, I'm just making sure that I'm
Yeah.
understanding.
Yeah. And you have to terminate with that because it needs to know how they're divided out. So if we just had a bunch of statements and I wouldn't know where one starts, the other finishes. It's kind of like a period in English, when a sentence finishes.
So if we use something other than person, we could say rabbit.
A rabbit.
In population, it wouldn't know what to make.
It wouldn't know what a rabbit is.
It knows that the population is constituted of that set of persons that we define.
Right. It wouldn't know what to make of a rabbit. In general, you need to tell it what this thing is. You might think it would automatically know about this, but computers are so awfully dumb in some ways, and actually there are languages where that would be true, and I've been nudging AnyLogic to get onto those languages, but right now in a language like Java, you have to tell it what these things are.
So if you didn't even put a person in there?
If you just said P in population, it would, I don't know what P is. Maybe P is a porcupine or something, right? Yeah. So you need to tell it kind of what is this thing I'm dealing with. Otherwise, it gets disoriented. And so I don't know what to do with this thing.
Are there any other elements besides persons within population?
Yeah. Yeah. Java tutorial. So yes. So it is time for lunch. So you can have other things besides persons within a population. You could have a model where the persons and their dogs represented, because if it turns out a dog walking affects people at these two levels, and so you might have dogs, and so you got to tell it, these are people that live here, and these are dogs that live here. Yeah. Does that make sense? Yeah. We'll discuss prospects for more tutorials of that sort after lunch. Okay. Thank you very much. Thank you for your patience. And once again, you've survived one of the more grueling sections of boot camp. We're almost done with the basic method. Thank you. So let's start at, so I have us down here as starting at, after 45 minutes. Okay. You think we could give people an hour? Yeah, say 1 o'clock? Yeah, sure. Sure, 1 o'clock. Sure.